Right, so still looking at the same section, we're just going to look at two more transformations. Yesterday we did the phase shift. Today we're going to look at what's called an amplitude change and a vertical shift. Okay, I'm going to start with the amplitude change. Right, so first of all, what does amplitude mean? Well, in terms of a sine or a cosine wave, amplitude is the height of the wave. Okay, and the way you measure the height, it's basically the distance from the center line to its highest point, which should be symmetrical with the distance from the center line to the lowest point. Okay. Yep.
So let's say you're measuring the amplitude of the wavelengths going below. Would you say it's negative, whatever the number is? That would be the height of it.
Well, let's think about height. Okay. What kind of number do you think a height always has to be?
Positive, obviously.
Positive. Yep.
So no matter if it's below or above, it doesn't matter.
Right. So the amplitude, we always describe it as being positive. Yep. Right, so the next thing to look at is where do we put the number in our equation to change the amplitude? Okay, we saw it for a phase shift. That's when we add or subtract in the parentheses. That's a phase shift. For an amplitude change, that's when we put a number in front. Okay, these are all examples of amplitude changes. Y equals 3 sine x. Y equals negative 2 cosine x. Y equals 1/2 sine x. Okay, so multiplying by a number in front, that changes the height, okay, or the amplitude. As I said yesterday, you can do multiple things at once. Like you could shift it left and change the height at the same time. Okay, but we're not going to do that. So each transformation that we study, that will be the only one that we're going to do in that problem. We're not going to combine multiple ones in the same problem. Anybody have a guess what putting a 3 in front would do to the sine function? It's going to change the height. You think it would make it taller or shorter? It does. It makes it taller. Okay, this is one of the transformations that what you see is what you would expect. Put a number bigger than 1 in front, it's going to make it that many times bigger. How about 1/2 sine x? It's going to make it smaller. In fact, it's going to make it half as tall. Okay. Now, forget about this negative for a second. What do you think the 2 would do? 2 cosine x. Take the amplitude and do what? Kelsey? Yeah, how many times higher would you think it would make it? Twice. Without the negative, 2 cosine x would be twice the amplitude as cosine x. Well, the negative is going to do something else. Okay, and I'm not going to talk about that yet. But we'll see an example when we get graphing. If all you want to know is what is the new amplitude of my graph, just take the absolute value of the number in front. Okay, why the absolute value? Because when you talk about amplitude, it's a height, it's a distance. Distance always has to be positive. Right, so we'd have some questions that don't ask us to graph it. They would just give you an equation and say, what's the amplitude? That's it. Okay, so let's practice a couple of those. Okay, let's do the ones we have up here. Okay. Y equals 3 sine x. What's the amplitude of y equals 3 sine x? 3. Yep. It means that it goes as high as 3, and it would go as low as negative 3. Okay, Emily, how about the amplitude of negative 2 cosine x?
2.
Yeah, it would be 2. Okay, just check the absolute value of A, and A is the number that's in the front. Okay. How about 1/2 sine x? Oh, Melissa, what would be the amplitude of that? 1/2. What would be the amplitude, Melissa, if I did put a negative in front? It would still be 1/2. Okay. So you might be saying, well, what does the negative do then? Well, to the amplitude, the negative doesn't do anything. But it does do something to the picture. Does anybody think they know what the negative is going to do to the picture? It's not going to change the amplitude. Yeah? It's going to cause it to flip. Yeah. So we'll see that it will flip. What was the highest becomes the lowest. What was the lowest becomes the highest. But as far as affecting the amplitude, a negative has no effect on the amplitude, just an effect on the picture. Okay. So basically, two things can happen with an amplitude change. Bless you. If the number in front has an absolute value bigger than 1, it's going to cause the graph to stretch. If the number in front has an absolute value of less than 1, it's going to cause the graph to compress. Okay, so if I put a -5 in front, that's still going to stretch it. Okay, think of the negative as something separate. Okay, the negative is going to cause your graph to do a flip. But it's the 5 part of that would cause it to stretch. If I put 1/3 in front of the sine or cosine function, that would cause it to compress. 1/3 is less than 1. Right, and we can take a look at what an amplitude change would sound like. Okay, we'll do that. Do that next. Right, so visually, this is what an amplitude change looks like. Okay, think of the one in blue as the original. Think of the one in red as the new one. Okay, that would be a compression. That would be a stretch. Okay. In terms of sound, what do you think changing the amplitude is going to sound like? Change the pitch. All right, so that's one thing that could change. What else could change about the sound? The volume. Okay, it's one of those two things. Let's just play. Okay, we'll play that, and I'll change the amplitude, and you can see what it would sound like. So what did it change? Yeah, it did. It changed the volume. Okay, so in terms of a sound wave, the effect on our ear is how loud we hear it. Did anybody ever study in physics, like X-rays or gamma rays or infrared light, ultraviolet, that kind of stuff? People kind of hear some of those terms before, though. So when you think about like radio waves, microwaves, X-rays, that kind of stuff, you can draw them as a picture, okay? And the higher up we get, that's called the electromagnetic spectrum. The higher up you get, what ends up happening is the closer and closer the wave starts to become. So eventually it's very close. Okay. As you start getting higher and higher in these waves, what happens is they get more harmful to humans. So you might start down here at like radio waves. Those aren't really harmful. Infrared, not really harmful unless you put yourself in a microwave and turn it on, or around that microwave range, that could be harmful. But in general, microwaves not that harmful. Then we start getting into like ultraviolet. Okay, wavelengths start getting a little shorter. Wavelength's the distance between those peaks. Okay, beyond that, we start getting into like X-rays. Okay, definitely can be harmful if you are exposed to them too much. And then we can get into like even things more powerful like gamma rays, which that's like from a nuclear reactor, things like that. Very harmful. Wavelengths that are longer, very easy to block. Okay? Even up to X-rays, we can block them pretty easily with lead. Okay? Thick enough lead will block an X-ray. When you start getting into these really dangerous waves, it's very hard to block. Does anybody have a guess what changing the amplitude of one of these kind of waves would be? It wouldn't sound louder because you don't hear X-rays. You don't hear microwaves. Stronger. Yeah. So if you had an X-ray that looked like this versus an X-ray that looked like this, measuring the amplitude, this would be a stronger X-ray, this would be a weaker X-ray. Right? So depending on what you're talking about, if you're talking about sound, it has a certain effect when you change the amplitude, versus if you're talking about something like X-rays, that has a different effect. Right? But same idea. You could think of it as increasing the strength. Okay? To an ear, that means louder. To an X-ray, that means like stronger, okay? More powerful X-ray. All right. We don't study electromagnetic waves that much, but in physics, you might look at that. Let's go back here. All right. Does everybody have that part when it stretches and compresses? All right. All right. So next step, most important step, is we got to make our table. All right, so now we're going to do an amplitude change. Okay, we're going to stretch or compress the graph on the y-axis. So what values are not going to change? If we're going to stretch it up and down, the x values are going to stay the same. Good. Okay, and I think when the x values stay the same, I think that's easier. Does anybody know why I think that's easier when your x values stay the same? Yeah?
So you're kind of like, you're used to finding, like, y is usually how you're trying to solve for most equations, you're trying to solve like that.
Well, what's harder about working with the x column than the y column?
There's pi.
Yeah, the x column has all the pi's in it, and it's all fractions. Right? The pi over 2, 3 pi over 2, all that stuff. Well, yeah, the y's are all zeros and ones and negative ones. So today, you're only going to have to do arithmetic with the number 1, 0, and negative 1. Okay? It's a lot easier to do arithmetic with the y's than it is with the x's. Okay? So for today, x's are not going to change. Right, so if the x's are going to stay the same, then the y's are what's going to change. Okay? How do we find the new y values? It's very simple. Take the old y values and multiply by a, where a is whatever number is in front. Okay, so in our next problem, a is going to be 3. Bless you. Notice here it just says multiply by a. It doesn't say absolute value of a. Okay, if there's a negative, use the negative. Okay, the negative affects the picture, causes something to happen. If it's a positive value for a, use the positive. Okay, but do not take the absolute value. The only time you take the absolute value is what I showed you way back at the beginning. If they ask for the amplitude, just don't ever give me a negative number. Okay? Amplitude has to be positive. All right, so let's try to make our sketch of 3 cosine x. All right, who can tell me why is this an amplitude change? Why isn't this one a phase shift? Yep.
Because it says y equals, right?
Phase shift said y equals as well.
Oh, it is?
Yep. Yep. Okay, there's no parentheses. Let me change that. Still an amplitude change.
It's kind of inside
Yep.
Number in front of cosine.
Yeah, we have a number in front of cosine, and what operation are we doing?
Multiplication.
Multiplication. Yep. So anytime you put a number in front and you're multiplying, that's an amplitude change. These parentheses I added here, they make no difference at all. Okay. All right, so we know it's an amplitude change. So Cody, what column stays the same?
The x's.
The x's. Okay, we're going to change the height. We're not going to do anything left and right. So copy your x's down from the original table. Ashley, do you remember what my original x's are? And they're the same for sine and for cosine. Yep.
Pi over 2, pi, 3 pi over 2, and 2 pi.
Good. Okay, so those are my original x's. Okay, now I'm going to find my new y values. If I want, I can put the old ones down first, just for reference, so I remember what they are. Becca, what are my original y values for cosine?
1, 0, -1, 0, 1.
Yep, those aren't my answers. Those are just the originals. And Sydney, what am I going to do with all 5 of those numbers? What am I going to multiply them by?
3.
Yeah, we're just going to triple them. So can you tell me what my new y values are?
It would be 3, 0, -3, 0, 3.
That's it. So there's our table for an amplitude change. Okay, now I'm going to fill in my axes. Okay, every single problem today, this is going to be your x-axis. Pi over 2, pi, 3 pi over 2, 2 pi. That will never change for every single problem we do today. What's going to change is my y-axis. Emily, what's the highest value that I have to go up to on the y-axis?
3.
3? And how about the lowest?
-3.
-3. So I decided to label my highest and lowest just as 3 and -3. And the last step, make your graph. So we got 0, 3, pi over 2, 0, pi, we're at -3, back to 0, and back to 3. And there's my graph. Any questions on that? You're going to notice today a lot of the graphs are going to look the same. Okay? For example, if you wanted me to sketch 6 cosine x, I would use that exact same picture. The only thing I would change is I would make that 6, and I would make that -6. Now that's the graph of 6 cosine x. Okay? So that's what we're going to do a lot today. Picture's going to look the same. We're just going to change our scale, okay, how we label it. If you don't want to do it that way and you really want to sketch something a lot bigger, you can. The disadvantage is you might run out of room. Okay, like if you had to sketch 30 cosine x and you were going to make it much bigger than this one, I wouldn't have enough space. Right? So I think it's easier just to relabel your y-axis than to actually draw a gigantic picture. Okay, question on that? All right, let's try a sine one. 1/2 sine x. Okay, Carter, before we do it, can you tell me what kind of transformation do you think that is?
That is,
Out of the 2 we've learned so far. Yep, it's going to be an amplitude change. You think it's going to make the graph taller than it is now, or is it going to make it shorter?
shorter.
Yeah, it's going to make it shorter. In fact, it's going to be half as high as the original. Okay. And last question, Carter, what axis does an amplitude change affect?
Y.
It affects the y's. Okay, so keep your x's the same. And Stephen, can you tell me my original y values for sine?
It was 1,
0,
Yep, 0,
1, 0, -1, 0.
0. Okay, so those are my originals. And Kylie, what am I going to multiply all these values by? 1/2. Can you tell me what I'd get when I do that?
Half.
So 0 times 1/2 gives me 0. Yep. And can you keep going? Tell me those other ones. So remember, these x's are staying the same, right? So for now, let's pretend we can't even see them. We'll keep them there, but we're just going to multiply these values by 1/2. Yep, which I'll just leave as a fraction. Okay.
Negative.
Negative 1/2 and 0. Good. And that's it. That's our table. So we just have to multiply the y values by 1/2. Okay, we'll make our graph. Okay, this time, let's make it a little smaller. This time the highest is 1/2. Lowest is negative 1/2. In x-axis, you're going to label it the same for every problem. Pi over 2, pi, 3 pi over 2, 2 pi. So if you didn't have those values memorized, hopefully by the end of today, you'll be sick of writing them and you'll know them. All right, so we got origin, 0, 0. Pi over 2 half. Pi 0. Negative 1/2, there's not much I can do other than maybe I should have put my label up above it, but or down further. That's fine though. And 2 pi back to 0. And there's my graph. Okay, and keep in mind what Carter said. This is half as high as the original. Okay, so the original would have been up at 1 and as low as negative 1. Okay, any questions on that one? So we'll do one more amplitude, and then we'll finish up with a vertical shift, which is actually a little easier than even this one. Okay, negative cosine x. Okay, so at first, when you look at that, you might say, well, he said an amplitude changes when you have a number in front. Technically, there is a number in front there. What number is in front? A negative 1. Okay. Do you think putting a negative 1 in front is going to change the amplitude? No. A negative 1 is not going to change the amplitude at all. But the negative is going to do something. Okay? Let's graph it and see what the negative does. Okay, so again, it falls into the category of an amplitude change, even though the amplitude really isn't changing, because you have a number in front. So Macy, can you tell me what my original x values would be?
For cosine?
Same for sine as well, but yeah.
1, 0. Or just start with 0.
For x's, it starts with 0, yep.
Pi over 2.
Mm-hmm.
Pi. 3 pi over 2. Pi.
Right, so those are my x's. And my original y's, we just did a couple problems. Back, 1, 0, negative 1, 0, 1. Hey, Malin, what am I going to multiply everything by here? Negative 1. So can you tell me what my new y values will be? What column are we changing? The y's. So these x's, these are done. We don't have to worry about those.
0, 1, 0.
And the last one, negative 1. All right, so the highest value is still 1. The lowest value is still negative 1. The amplitude didn't change. But what do you think is going to happen when I graph it? Yeah. Yeah, it's going to be upside down from what we're used to seeing. Okay, so cosine You're used to seeing something that looks like that. That shape is going to flip. Okay, so we're at, label our axes. And we're at 0, -1, 0, 1, 0, -1. So now instead of a V shape, you're going to get more of like an N shape, upside down V shape. And remember, your graph would continue in each direction. Okay, that's one thing I should mention. For anybody who wasn't here yesterday, these graphs continue forever. They have this wave going left and right forever, but we're only sketching one section. Does anybody remember what we call one section? Actually, we have 2 words for it. Yeah?
Is there one like a period or something?
Yep, one period of the graph, or does anyone remember the other word we can use, but we don't as much? What is it?
Cycle.
Yeah, a cycle. You talked about that with like electricity and frequency, stuff like that. Okay, so that's one period of this graph. Okay, any question on that one? All right. Okay, so last thing we're going to look at is a vertical shift. Okay, vertical shift is probably the easiest transformation to do. It's even easier than multiplication. All we have to use is addition this time. And it has the form sine, could be sine or cosine. Sine or cosine of x plus or minus a number. Okay, these are both examples of vertical shifts. Now I thought when we added or subtracted something, that was a phase shift. So why is this a vertical shift? What's the difference? We're still doing addition and subtraction, just like a phase shift. That's a D, yeah. Yeah, what we're adding and subtracting is not in parentheses. Okay, that's a huge difference. If I put parentheses around the letter and the number, I turn it into a phase shift. What do you think sine of x plus 2? What do you think the plus 2 is going to do? Yeah, we would hope if we use common sense that a plus would be up and a down would be minus, and that is the way it works. So this is the second transformation that does what you would expect. The first one is amplitude change. Bigger numbers make the graph bigger. Smaller numbers make the graph compressed. Vertical shift, positive numbers are going to move it up. Negative, move it down. Okay, so vertical shift moves it up if you add, down if you subtract. All right, so we're going to move it up and down. So what column this time? The x's or the y's? You think we can leave alone? We don't have to do anything to it. Yeah, the x's again. Okay, if you shift something up or down, you're moving it on the y-axis. Okay, you're changing the y values. You're not touching the x's at all. Okay, so to find your coordinates for a vertical shift, same first step as an amplitude change. Copy down the x's from your original table. And the last step, if the x's are going to stay the same, then the y's are going to change. All you have to do is take whatever number is on the end and add or subtract that to all your original y values. If you have a plus 2 at the end, I want you to do a plus 2 to all your y values. If you've got a minus 3 at the end, do minus 3 to all your original y values. Now, thinking about what you know about a phase shift, what mistake do you think people make with a vertical shift that you shouldn't do? They do the opposite. You do not do the opposite. Okay, that's just something you have to keep straight somehow. With a phase shift, you do the opposite. With a vertical shift, you do not. Okay, the other mistake I see quite a bit is people accidentally do these as phase shifts. And then I usually say if there's no parentheses around the x and the number together, it's not a phase shift. Okay, so any question on the difference between a phase shift and a vertical shift? Just in how the equation looks. All right. So let's look at sine of x plus 2. I think that was the first example I gave you guys. Okay, is that a phase shift? Sine of x plus 2. Is it a phase shift? No. Okay. What would it have to be a phase shift? You would have to have parentheses. Okay. What if I do this? I put in parentheses. Is it a phase shift? No. Where do the parentheses have to be? Like this? Okay. If you put in what I just did there, that didn't change anything about the problem. Okay, we don't even need what I did there. But if I did this, okay, now it's a phase shift. Okay? Now it's a vertical shift. All right, so arcade, since it's a vertical shift, what values stay the same? The x's. Okay, x's stay the same. Okay, so copy them down. Does everybody have what's on the left so I can make the right bigger? Zero, pi over 2, pi, 3 pi over 2, 2 pi. Okay, Austin, what are my original y values for sine?
0, 1, 0, -1, 0.
0. Good. And Natalie, what am I going to do to all these y values?
Add 2.
Yep, I'm going to do plus 2 to each one. Can you tell me what I'll get if I do that?
2, 3, 2, 1, 2.
Okay. That's all you have to do, do a vertical shift. That's the whole problem. Any question on the table? Okay, last step, just to make our graph. Okay, Stephen, what's the highest y value I need to go up to here?
3.
Yeah, I've got to go all the way up to 3, so we'll just label it 1, 2, 3. Okay, x is labeled in the way I told you for every problem today. And I would definitely suggest putting your labels below because you know you're shifting the graph up. So your graph is not going to be drawn through your labels this time. All right, so we've got 0, 2. We've got pi over 2, 3. Back to 2. Down to 1. Back to 2. And there's our graph. Okay, what if I asked you the amplitude of that picture? What's the amplitude of that graph? Wes? Well, 3 is the highest value that it hits. But remember, that amplitude is measured, think of it as the distance from a center line, if I put that in. Yeah, the amplitude is 1. There's no number in front of it. Okay, if you don't put a number in front, the amplitude is always 1. But if I asked you what is the highest value that it hits, you are correct saying 3. Okay, any other questions on that? All right, so why don't try that one on your own. Okay, see if you can figure out the table. Okay, make a sketch, and we'll finish up with this one. All right, let's take a look at y equals cosine x minus 5. All right, so because the minus 5 is outside the parentheses, we know it's a vertical shift. Hey, Nick, is this going to be up or down?
Down.
Yep, it's going to be down how many units?
5.
Down 5. All right. Okay, so because he told me it's going to go down, I'm not going to worry about changing my x's. I'm going to copy them from my original table. 0, pi over 2 pi, pi over 2, 2 pi. Okay, and Amy, can you remind me my original y values? Don't worry about minus 5 yet.
1, 0, -1, 0.
Perfect. So that's going to be your starting point, and you're going to take all those values and shift them down 5. Taylor, can you tell me what you get if you subtract 5 from all those?
4, yeah, 4, oh my god, I'm sorry. Oh, so 1.
So 1, take away 5.
I'm having a brain fart.
It's all right. Think
4.
4. Well, you're taking away more than you have, so you're going to have a
Negative.
negative. How about 0 minus 5?
Negative 5.
Yep. Okay, negative 5. And then negative 1 minus 5?
So negative 6.
Yep. Good. Negative 6.
Negative 5.
Back to negative 5.
Negative 4.
We always end back where we started. Good. Okay, so that's it. There's our table. This time, I'm not going to worry about labeling things on the positive axis because it's not going to be in that part of the graph at all. Just label down to negative 6. If I had to go really far down on the y-axis, I might go by 2s, like negative 2, negative 4, negative 6. But in this case, I can go by 1s. And I'll put my labels. I'd write them up above, but I ran out of space. So I'll just put them right here. All right. Oops, why did I label 0? See if I can just move these over. All right, so let's see. Pi over 2, that's negative 5. The first one, I skipped 0, is negative 4. Pi, we're at negative 6. Back to negative 5. Back to negative 4. And that's our sketch. As far as a connection with sound, this one shifting up and down doesn't really have any connection with sound. We saw what phase shift is. We did the amplitude change. And tomorrow we'll finish up with our last transformation, which stretches and compresses things left and right. Okay, that one's probably the most interesting in terms of different things we can do. And we'll see some things I can do with a cell phone and some connections to frequency and like the military. And I'll show you some different things about sound frequencies tomorrow. Okay. So homework tonight, again, is just a worksheet. Okay, 5 questions, just like last night. Homework will be in the video if you lose the worksheet. Graph paper is already drawn for you, so you don't need to worry about that. And again, no tests this week due to Good Friday and snow day Monday.